This video is all about lesser known tips and tricks that I actually use myself daily, and I have no doubt they will change parts of your post-3D printing routine too. So without further ado, let's see which things have proven themselves over the time and are not just gimmicks. To start with, the thing I use most often after a 3D print finishes is this stand for hot flex plates. You should never remove the plate immediately when printing larger models, but when printing smaller PLA, PTG or even ASA parts, I almost never wait for them to fully cool down inside the printer. You might ask, what is the point of such a stand if we can't just place a flex plate on anything that will withstand the heat from it? Well, unless you clean the surface before setting the plate down each time, it can attract all kinds of dirt and debris. With a stand like this, printed from ASA, ABS or at least glass fiber or carbon fiber filled PTG, you can simply take out the plate and place it on any surface without worrying about it. When I'm feeling extra YOLO, I even use an additional fan to speed up the cooldown, but only when parts are very small. Basically, the bigger the part, the more time it should spend cooling down inside the printer before you remove it. This is because after printing is done, the bottom layers are still very hot and slightly soft, and forcefully bending the plate can permanently deform them. However, even after the plate has fully cooled down, some prints, especially PTG, can still be difficult to remove. On top of that, the bottom surfaces often develop stress marks similar to ones you see when you bend the filament. To solve these problems, there are some great solutions. The most annoying thing to remove are those thin skirts and brims. Having a proper scraping tool completely changes how easy they are to remove. I used to print such tools, but they are just no match. I also found that spraying some rubbing alcohol in both sections makes the process even easier. There are plenty of scraper options to choose from, and you can even print one yourself. All you need are the blades, so there is really no excuse not to have one. And if nothing else helps, print a 2-layer sheet over the problematic area. It will pick up the filament leftovers embedded in the plate. When it comes to those stress marks on the bottom of prints, people often say a heat gun is the best way to get rid of them. But in my experience, the fastest and most convenient solution is a small blowtorch. The goal is to slightly melt only the outer surface of a print so it becomes shiny while spending as little time as possible, for obvious reasons. It is almost instant, gives great results, but does require some experience, as using the wrong power settings, distance or moving too slowly can ruin the print very quickly. Plus, it is an actual blowtorch that can set things on fire, so don't be careless with it. If you know what you're doing, it is an amazing not only for fixing those surfaces, but also for instantly removing stringing from prints. Just don't buy a blowtorch that isn't powerful enough. It makes the process far too slow. The most important thing is that it would have plenty of adjustable power and feel comfortable in your hand with quick on and off switch. Speaking of control and comfort, what if you don't have any? During this video I was designing and making probably the silliest thing I have ever built. The tip here for makers is that plastics can withstand quite a lot of force when it's secured to metal parts with a large enough contact area. This is where today's video sponsor, PCBWay, comes in. They manufactured this beautiful aluminum anodized adapter to do exactly that, provide more surface area for mounting this plastic ship wheel printed from the updated bamboo PTG. I'll be experimenting with a lot of silly things to mount, so having metal threads for repeatedly screwing in different designs will greatly improve the durability. So if you need all sorts of professional advanced manufacturing capabilities for your projects, be sure to check out PCBWay using the link in the video description. When it comes to making all sorts of things, sometimes you simply have to use a brim to make sure the parts warps as little as possible and stay securely attached to the build plate. I already explained in detail why warping happens in the first place and how to reduce it, but if you use brims, a deburring tool is a must-have. Removing brims with this thing is an absolute breeze. It is day and night compared to using a regular knife, and it is much safer too. However, one of the best hacks, and the one I have been using the longest, has to be this trick for installing very commonly used heat inserts. All you need is some brass tips for your soldering iron, heat it up, press the insert in, but not all the way, and then use almost any flat metal object to press it perfectly flush. It works wonders every time, and there is no need for a dedicated heat insert station. It is simple yet incredibly effective. When it comes to filament management, a universal drill adapter for quickly respooling filament is something I use far more often than I ever expected. Got a filament with an unconventional spool that doesn't fit where you need it? Just place the original spool on anything that lets spin freely without too much friction, attach an empty spool to the drill adapter, feed the filament through a PTFE tube as a guide, and let the drill do the hard work. It takes some practice, but it is by far the fastest way to respool filament and be done with it. I often use it when I want to combine a few partially used spools into one. That also requires filament fusing, which I'll be honest is a little bit of a janky process and almost always takes a few tries. Because of that, I mainly do it with two spools that still have a decent amount of filament left. It is a great way to organize and clean up your workspace. When it comes to storing filament, a good spool design makes life easy. Meanwhile, a poor design is annoying, as it not only wastes filament but also needs cutting off the bent end each time you use it. In those cases, I just clamp the ends of a filament with these simple filament clips. There are countless designs available, but after trying different ones, I always end up printing more of these. They are just simple, yet very effective. If you care a lot about print quality, you are probably trying to keep your filament as dry as possible. That usually means printing containers for desiccant and storing them together with your filament. The annoying part is sealing the bags and putting them back into the box, especially with those aluminum foil bags. They just don't want to go back in. Quite recently I had an idea. Why not print an adapter for these inexpensive yet surprisingly powerful blowers that would suck air out instead? Well, it worked even better than I expected, and it has become part of my filament storage routine. Keep in mind that none of these bags have a perfect seal, so they will slowly let air back in over time. That is why I put them back into the box, as it helps limit that expansion. However, for precious engineering filaments such as PC, PET, PA, PPS or PPA, I use double protection, desiccant containers inside aluminum foil bags, plus extra desiccant inside a large sealed box. This one from IKEA is very popular and holds 4 spools. All you need to do is seal the lid with window sealing tape and print several clamps. This keeps your pricey filaments dry much longer. So these are my genuine tips and tricks that I actually use on a regular basis and not just clickbaity things that often are just gimmicks. These things work great for me, so hopefully some of them will be useful to you as well. If you have any great tricks of your own, make sure to share them in the comments. I always love hearing what actually works well. Huge thanks to PCBWay for sponsoring this video and to everyone who supports my work on YouTube and Patreon. Well, that's all for me, and we'll see you next time.